attention today, I love inverses. Inverses are my favorite lesson. Man, not my favorite. Common base, exponentials, and solving logs are my favorite. This would be my third favorite lesson of all of them. Because if you pay attention, it's just the same things over and over and over. All inverses are your coordinates flip. So, an example would be, mapping-wise, xy just becomes yx. That is it. That is all. That is it. Literally. Your x's become your y's become your x's. That's all inverses are. So, if my x's become my y's and my y's become my x's, that means everything on my original will flip on the inverse. So an example would be, my domain of my original will be my range of my inverse. That's it. My range of my original will be my domain. My x-intercepts of my original will become my y-intercepts. My y-intercepts will become my x-intercepts. That's it. What coordinates would stay the same if I flip x's and y's? What coordinates would remain invariant, which means stay the same? 0, 0 is 1, that would, yeah? What else? If I flip it, it would stay the same. 2, 2, 3, 3, 4, 4, negative 1, negative 1, negative 2, negative 2. Those are often the ones that everyone gives me, and those are correct. There are also other coordinates in between those coordinates. Like people like 0, 0, 1, 1, but you skipped all the decimal ones that fall in between there, right? Like 0.25, 0.25, 0.75, 0.75, 0.6666222, 0.6666222. Like those are still coordinates that if I flip them, they would be the exact same. Correct? So where are these located? Well, the invariant points for inverses are on the identity line. What the heck is the identity line? Well, you just told me 0, 0, 1, 1, 2, 2, 3, 3, negative 1, negative 1, negative 2, negative 2. And then I told you 0.25, 0.25, 0.77, 0.77, right? So what are we doing? We're stating when the x's and y's are the exact same, are we not? Technically, when the x's and y's are the same, if I flip them, it stays the same coordinate, does it not? The identity line is just the line where that happens. It's the line y equals x, which makes sense. It's the line where every y equals every x. So if I flip them, they stay the same, right? So that's the identity line. It's the line y equals x. It's 0, 0, 1, 1, 2, 2, and all the connected ones in between, including all the decimals. Okay, so I just told you, if it says inverse, it means the x and y's flip. The other ways they can ask for inverse, instead of just saying inverse, they could say it reflects in the line y equals x, because that is inverse. It could say y equals f negative 1x. That is inverse. It could also say x equals f of y. That's an inverse because they flip the x's and the y's. Or they could use the word inverse. All four of these are different ways of saying, hey, find the inverse. Now, do I actually have to find the inverse if I want the domain and range of the inverse? Do I actually have to find the inverse equation if I want the domain and range of the inverse? No. If I have the domain and range of the original, do I indirectly have the domain and range of the inverse? Yeah. Because the domain, if it's xer, will now be the range, which will be yer. I literally just take the x's in the domain. The domain is xer. Cool. I take all the x's, I'm like, throw them out, replace them with y's. Oh my goodness, it's a range. There it is. Because all you're doing is switching the x's and y's. That's it. So the only time you actually have to find the inverse equation is if it asks you to determine the inverse equation. Other than that, off of the original, you can state everything that the inverse has, because it's just the x's and y's flips. X-intercept become y-intercepts, y-intercepts become x-intercepts, etc. So here's a case where you actually have to find the equation. So here it says the graph of y equals f of x equals x minus 5 squared is shown. We're going to draw it ourselves below in a second. Now it says write an equation for the y equals f negative 1x. This just means write an equation for the, oh, I hate this board so much. Go away. Go away. All right. This just means inverse. It's a fancy way of saying inverse. Now, some people will sit on the test and they'll be like, I can't find the equation of the inverse. I don't even remember what the frig to do. Like, I'm going to stare at this for life. When you say inverse, what should you immediately think? X and Y switch, right? Inverse, X and Y switch. Inverse, X and Y switch. That's it. You remember inverse, X and Y switch, you should be able to answer every single question. So if I want an equation of an inverse, what's the very first thing I should possibly do? Switch the X and Y. That's it. So my equation before was, I hate this, really long Y. Cool. X minus 5 squared. That's what my original was, correct? I want the inverse. So I should switch my X's and Y's. Technically, poof, I'm done. That's the inverse equation. And sometimes I see multiple choice questions where people can't figure out the inverse because that's all they did. They switched the X's and Y's and gave you that as a multiple choice option. Easiest thing ever, right? But you guys are going to go isolate it for Y, and you're like, it's not there. But they just literally just plugged in X's and Y's and poof, they were done. Okay? So technically, that is the inverse equation, but 99% of the time, they get it into Y equals after this. So all you have to remember to find an inverse equation, you swap the X's and Y's, and you're done, actually. But then you look at the multiple choice, and you're like, oh, they're in Y equals. So you have to keep going to just isolate Y. Okay? So we swap the X's and Y's, and now I need to get Y by itself. Well, how do I get an equation by itself, or a variable by itself? I do reverse BEDMAS, correct? So what's our first issue here to get that Y by itself? The squared, right? How do I get rid of a squared? Square root. And this is where the issue lies. People will square root, but they will forget that every time you physically take the square root, not the square root is given to you, you physically, your hand does the square root motion, it also needs to have a plus or minus sign in front of it. The moment your hand does the square root motion, it has to have a plus or minus sign in front of it. And those cancel. So now I have plus or minus square root x equals y minus 5. And now how do I get y by itself? Add 5. Does it go under the square root sign? Is it currently under a square root sign? No, so can it go under the square root sign? No, it just sits the back. It's a vertical translation. So we can leave it in y equals, or we could go f negative 1x plus or minus square root x plus 5. Do you see how there's going to be a chance you might forget the plus or minus sign? If you're someone who's like, I was not going to write the plus or minus sign, these are your notes. This is where I would put a star, 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 and a little highlighter, and I would say, every time I physically take the square root of something, I need to put the plus or minus sign in front of it. Remember, these are your notes to go back and remind yourself, however that may be. But if I'm someone who knows I didn't put that plus or minus sign, I wouldn't have done it. I go plus or minus sign, square root, circle it, star it, put a little arrow to it, and I'd say, every time I physically take the square root of something, I need to remember to put a plus or minus sign in front of it. So if it's square root x plus 5 and it's given to you like that, you don't go put a plus or minus sign in front of it. Like if it's a typed equation and it's square root x plus 5, poof, that's it. When you physically take the square root to get rid of a squared, you put a plus or minus sign in front of it. It's only when you take the square root yourself with your own pencil. All right. So if we go to draw this graph, it's x minus 5 squared. Type it into your calculator. It's actually the quadratic moved 5 to the what? 5 to the right, correct? So I'm going to go x scale 1, and I'm going to go y scale 1. And I could just label it as the f of x graph, because it is just the f of x graph. We're just typing in the original. This is the x minus 5 squared graph. when I have the original, do I need to actually use the equation to draw the new one, to draw the inverse? Absolutely don't. I can use mapping. The only time I have to find the equation of the inverse is if it says determine the equation of the inverse. That is it. Because if I have a graph, I'm like, cool. I just take all the points, I do this to them, and I redraw them. That's it. Every x becomes y, every y becomes x. That's it. People overthink this lesson so much, I can't even explain it to you. It is a really easy lesson that people overthink and do terrible on. Just take your points, flip them, redraw. Take your point, flip it, redraw, right? So my coordinate is at 3 and 4. It's now going to be at 4 and 3. And I move to the next sequential one. And I say, okay, this is at 4 and 3. 4 and 3, oh my goodness, it is not. It is at 4 and 1. It's now going to be at 1 and 4. And then I get my vertex is at 5, 0. It's now going to be at 0, 5. And then I know it's connected, because that's one of the arms. And then I keep going. Okay, then we get 6, 1. And it's going to be 1, 6. And then we have 7, 4 is going to become 4, 7. Now some people might say, how is that an inverse? What was it reflecting on? What did I tell you? It reflects on the identity line. What's the identity line? Y equals x. So I'm going to draw that y equals x in here. Sorry, I should have labeled this red one first. The red one is f negative 1x, because that says it's the inverse. Then I can put my identity line in there. So the identity line goes through 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. And then we just dash line it. It's supposed to be dashed lines, but it drew it all together. So nice of it. Where are, or actually, how many invariant points are there? On this graph, it looks like 1, but we know this graph will keep going. So how many are there going to be? There's going to end up actually being 2. The invariant points fall on the line y equals x, correct? Because if I draw the line y equals x, if any of the graph crosses there, it should stay the same, right? Because on that line, your y's and x's are the same numbers. So it should flip and should be the same. So if I look here, here's one of my invariant coordinates. Do you see it's crossing? And then up here somewhere, this graph's going to carry up, this graph's going to carry over, and I'm going to get 2 invariant points. Do you see that? So wherever that graph is going to cross on the identity line is where you get the invariant points. So if you're ever asked for how many invariant points there are on an inverse graph, you literally just draw the line y equals x and count them. Did I even need to draw the inverse graph to figure that out? No, I can just draw the identity line on the original, and where it crosses, the inverse is going to cross. I don't even have to draw the inverse. So I marked the invariant points already. And then how did the graph of y equals f of x compare to the graph of y equals, or f negative 1x? It's a reflection. This is aggressively thick. in the identity line. Now everyone will be able to see this, no matter where they are in the room. So everything I do is curriculum-based, right? You have to do everything based off the curriculum. They give me a curriculum, I have to teach it to you. Okay? So they tell us we have to do transformations. We have to do vertical translations, horizontal translations, reflections in the X and the Y, stretches vertically and horizontally, and then your vertical and horizontal translations. And then they tell us we have to do inverses. Okay? Now they tell us that they can ask anything about the inverse. They can ask for the equation of the inverse. They can ask for different things off the graph of the inverse. They can ask for invariant points. That's something we have to learn. But we also have to teach you, in the curriculum it states, that I have to teach you how to make the inverse of a function, how to restrict the domain of the original function so that the inverse is a function. What the heck does that mean? Okay. If I give you this, you don't have to write this, I'm just proving a point. If I give you that, how can I tell if something is a function? Well, I can do a vertical line test. The vertical line test states that for every x, there's only one y. So if you do vertical lines and it only crosses through once everywhere, it's a function. So if I go do these yellow vertical lines through this whole graph, pretend those are perfectly vertical because they're slanted. They're supposed to be perfectly vertical. Imagine. Okay? Are they crossing through once on that graph? Right? Every single one of them is crossing through that graph once. We agree? So the original is a function. But if I draw the inverse of that one, this here is at, let's say, -3, 0 and -3, so it's going to be here. And this would be at like -2 and 2, let's say. So now it's going to be at 2 and -2. I'm getting a graph that looks like this. Is the inverse a function? Let's do some vertical lines through it. Ah! Darn it. It crossed through twice. It's not a function. We agree? So the curriculum outcome I have to teach you is, how can I restrict the domain of the first graph, the original, so that when I draw it, the inverse can draw vertical lines through it and it doesn't cross through more than once. We agree? So, if I keep this whole graph, it has two arms. We agree? If I draw both arms, it ain't passing the vertical line test. We agree? If I draw one of the arms or the other arm, would it pass? Like, for example, if I got rid of this arm here, and I just said this, would it pass? Yep. If I kept the bottom arm only, would it pass? Yep. So what do I have to do to that original graph so that I only get one arm? Pardon? Take one of the arms off. How do I take one of the arms off? I restrict the domain. Because the domain is the x's, correct? So if I looked at this graph here, that was not a swear board. Someone was in the hallway. All right. So if this is the board, this is what's happening when they're swearing in the hallways and I have no control over it. Okay. This is the graph. And it splits, let's say it splits at 3. That's what I care about. I care about where the heck that graph is splitting. What x value is it splitting on? Okay? This is the original. So if I made my domain, the domain of this one is XER technically. The original domain is XER. Yes? The graph goes on for life. I can get x's this way, I can get x's this way, and then it goes on for life. We agree? I'm going to blow my elbow one of these times when I do aggressive domains. It's going to happen. I'll just be like, excuse me while I put my elbow back in. It's just going to happen. Gently. Gently. We're going on for life. We agree? But if I just keep this arm, I'm only keeping x from the vertex left. So less than the vertex x value, right? If I keep this arm, I'm only keeping greater than the vertex x. Yes? So, are there options of how I could restrict this domain? Or is there only one way to restrict this domain? There's options. I could say, okay, I want x such that x is greater than or equal to 3, XER. And then what am I only keeping? That. And when I draw it, will it pass? Yep. Or I could do x such that x is less than or equal to 3. And then I would only keep this arm. And it would pass. Yep.
We have to, like on a test, would we have to do the double lines?
Everything.
Real? No, like for the...
Oh, if you do just an R without a double line, no.
Okay.
In university, you might get in trouble.
Okay.
But we, as mathematicians in Alberta, marking your diploma, won't.
Okay.
If you write it as a little r, yeah,
Yeah.
that's not the same thing. Yeah. So as long as it's an R without a double line, you're golden. In university, they'll always put them as a double line. R. We also use I's for integers, and in university, it's not an I, it's a Z. Yeah, with a double line and a little line. And,
Do you have to restrict it from the vertex?
no, so you can get restriction. You can get you can have a party and restrict so many things. Like you could restrict greater than or equal to 4 or greater than or equal to 5, and you'd still only have this piece of it, and that would still be good, right? Or you could restrict less than or equal to that. Do we agree? Like you can do stuff like that. So that's what we're going to talk about too tomorrow. So tomorrow we're finishing off inverses, and we're starting polynomials. Okay? Your hand-in was supposed to be due on Tuesday, with full realization in my head before you left that I was going to make it Thursday, but I thought putting it Tuesday would make you have some little bit of stress levels, but half you didn't even know that I assigned it, so, or 90% of you. So it's due Thursday. So tonight I am not assigning inverse homework because I'm expecting that you're working on that transformations hand-in. Okay? I have it printed, I gotta go grab it.